Hello, this is Khurram Nasir and you're watching Optometry with Khurram, and I have received many emails, messages and comments that, sir, please put regular videos on contact lenses. But you know very well that I have so many national and international commitments. I have to go to the university, I have my personal clinic, I'm running, the online and physical courses on optometry, but still I'm trying my best to be consistent on my YouTube channel as well. So, you know very well that on contact lenses, we have a brief video, the last video, on the parameters of the contact lenses. We have discussed about the diameters and base curves, the optic zone, etc. We have a detailed video on the parameters of the contact lenses. But now in this video, we are going to learn about that how we can measure, how we can order the best diameter in soft contact lenses for the patient, right? How can we order, how can we measure the BOZR, the base curve in soft contact lenses for the patient, right? So first of all, we will discuss about the diameter, right? So diameter, you know very well that actually if this is the contact lens, we have discussed in the last video, this width, right, the widest width of the contact lens is called the diameter, right? And the basic concept about the diameter is, if I increase the diameter, the lens will be more steeper, right? We have discussed in the previous video in very detail. For example, if this is the diameter, this line is representing actually the diameter, right? And if I increase the diameter, you see, I increase the length of this line, the lens will be more steeper. You see, the lens is more steeper as compared to this one. So as I increase that diameter, the lens will be more steeper. This is the basic concept, right? So to measure the diameter, we have to measure the HVID, HVID, right? This is very simple. This is very easy. HVID mean horizontal visible iris diameter, right? If, for example, iris is, the colorful structure of the eyeball. So this is the iris, and this line, we have to go in horizontal way, right? So this is the 360-degree iris, and this line, this horizontal line, is actually representing the HVID, the horizontal line. This horizontal line of the iris is HVID, horizontal visible iris diameter. So you will put a scale on the iris, the 0 mark will be here, and that the value at this point will be total HVID. So for example, the supposed value of the HVID is, for example, 12 millimeter. This is a supposed value, right? And then how can we find the total diameter, the TD, total diameter of the contact lens or the soft contact lens? So we can find the total diameter with HVID plus 2, right? So we will add plus 2 millimeter in the HVID. So HVID is 12 millimeter and 2 is the value, right? Because we need a steeper contact lens, so we will add 2. So the total diameter will be 14 millimeter, right? So we're increasing the diameter, right? So that's why we are increasing the value of 2. So HVID plus 2 will be total diameter of the soft contact lenses, right? So now we will discuss about the different certain conditions, right? So for example, if the refractive error of the patient is so high mean it's up to 10, 12 or more than that diopters, for example. So we are putting some conditions. If the refractive error is greater, right, is high, right, then what will we do? We will add 0.5 millimeter in the total diameter, right? 0.5 millimeter. And the next is, for example, if the water content is high. So if the refractive error is high, we will add 0.5 millimeter, right? If water content is high, then we will add the same 0.5 millimeter in the total contact lens, in the total diameter of the lens. So for example, our total diameter was, HVID was 12 millimeter, we add 2, right? The total was 14 mm, for example, right? And we will add 0.5 if the water content is high. So we will add 14 plus 0.5 and it will be 14.5 millimeter. So in high refractive error or in high water content, we will add 0.5 to the total diameter, right? So let's make a chart. And why we are doing this? The question is why we are doing this. Remember, as we have know that if we increase the diameter, the lens will be more steeper. Remember, so for example, if the refractive error is high, for example, so it means that refractive error is high, it means the lens carries more weight. So if the refractive error is high, the lens carries more weight. Because the refractive error is high means the thickness will be increased, and when the thickness will be increased, the lens will be more weight, right? The lens will carry the more weight, right? So same is the with the water content. So if the water content is high, then it means that the contact lens carries more weight, right? So in both cases, the contact lens is getting more weight, right? Contact lens is heavy. So due to this weight, the contact lens will move on the surface of the contact lens, right? It will move. It will, when the patient will blink, the contact lens will get an excessive movement on the surface of the cornea. So it can damage the cornea, right? It will not fix on the cornea, right, in a normal fashion. So what will we do? So on that behalf, for that sake, we will increase 0.5 millimeter when the refractive error is high, or when the water content will be high. We will add 0.5 to make the contact lens to properly fit on the surface of the cornea. If the refractive error is high, lens will be more weight, right? Lens will carry more weight. If the water content is high, lens will carry more weight, and then the thickness will be increased, right? And when the thickness will be increased, there will be more lid and contact lens interaction. This is called lens and lid interaction, right? So lens and lid interaction will be increased, right? So lens, the wearer will be not comfortable with that. So to fix the cornea, to fix the contact lens on the surface of the cornea, we will increase 0.5 millimeter in the total diameter, right? So by increasing 0.5, if the refractive error is high, it will make the lens to fit on the surface of the cornea. It will envelop the cornea properly in a normal fashion, right? If the water content is high, we will increase 0.5 millimeter, and in that fashion, the diameter will increase, and when the diameter will increase, lens will be more steep, right? And it will fix on the surface of the cornea in a normal fashion, right? So that's why we increase 0.5 and 0.5 if the refractive error is high, more than 10 diopters, and if the water content is high, then we will add 0.5 millimeter in the total diameter. So let's learn this condition in this with the help of this table. So this is refractive error, this is WC mean, the water content. For example, if the refractive error is low, what will happen? If the refractive error is medium, what will happen? If refractive error is high, what will happen to the diameter? If water content is low, medium or high, what will happen to the diameter? What will we do to the diameter of the contact lens? So we have discussed already, if there is low refractive error amount is less, the value of refractive error is less, then we will simply add 2 mm in HVID. Simple, right? And if, for example, the refractive error is medium, right, up to 5, 6, then the same, we will add 2 mm in HVID. Now, if the refractive error is so high, more than 10 or more than 12, right? So in this case, we will add 2 mm plus 0.5 mm in HVID. Remember that, right? So in this case, if the water content is low, we will add 2 mm in HVID, the same, right? If the water content is medium, then we will add the same 2 millimeter in HVID, right? And if the water content is so high, then we will add 2 mm plus 0.5 in HVID. And I hope you can see the different parameters regarding the refractive errors and the water content. If low, if medium, if high, right? And low water content mean it's about, up to 40%, and medium water content mean it's 40 to 60%, and high water content mean up to 60 and more than 60, right? So I hope you have the idea that how can we calculate the proper total diameter in normal conditions, or in high refractive errors, or in high or low or medium water content. So now let's discuss about the BOZR, the base curve. So you know very well that what is actually the base curve, right? Base curve of BOZR. Base curve, we have a detailed discussion on the base curve of the BOZR. BOZR, you know very well that back optic zone radius. So for example, if this is the contact lens, if this is the circle, this is called, this line is actually representing the base curve, right? The smaller circle, you know, this is the smaller circle. So you see, if we considering this portion as the contact lens, so you see the contact lens is more steep, right? And if I make a circle bigger than this one, this is a bigger circle, right? And this is the base curve. You see, in this condition, when the base curve is small, the lens is steep. If I increase the base curve, you see, increase base curve. If I increase the base curve, you see the lens is flatter, steeper if the base curve is small. I increase the base curve, the lens is getting flatter. So it means that the basic concept, if I increase the base curve, the lens will get more flatter. The fitting will be more flatter. So this is the basic concept. So let's learn that how can we find or how can we measure the BOZR or the base curve. Both are the same. How can we find the BOZR or how can we find the base curve of a contact lenses? We have different methods. So the method number one is, for example, this is K1 reading and this is K2 reading. So for example, K1 is 8.0 mm and K2 is 7.6 mm, right? So the method number one is actually add 0.3 to 0.9 in the flattest K reading. So you tell me that which is the flattest one. We have discussed that when we will increase the base curve, consider this as base curve, right? When we will increase the base curve, so you tell me 8 is bigger one or the 7.6? 8 is bigger, right? So when we increase the base curve, right, the lens will be more flatter. So it means that 8.0 mm is more flattest, right? So we have to add 0.3 and 0.9 in the flattest K reading. So in both of the K readings, the 8.0 is the flattest K reading. So right. So now we will add 8.0 plus 0.3, right? And 8.0 plus 0.9. So we will add 0.3 and 0.9 in the flattest K reading, right? So 8.0 plus 0.3 will be 8.3, right? And 8.0 plus 0.9 will be 8.9. So it means that we have a range from 8.3 to 8.9. So we can prescribe the range of base curve from 8.3 to 8.9. We can prescribe 8.3 if we have. We can prescribe 8.4, 5, right? 6, 7 or 9. We can prescribe between these ranges of the from 8.3 to 8.9. This is called the method number one. And now we will discuss about the method number two. So the method number two is simply add 1 millimeter in average K reading. Average K. So we have to find the average K. So for example, we have K1 and we have K2. K1 is 8.0, the same, and K2 is 7.6, right? So we have to find the average first. So we will add K1 and K2. So 8.0 plus 7.6 over 2. This is, we are finding the average. So 8.0 and 7.6, it will be, I think, 15.6 if I'm not wrong, over 2. And then it will be 7.8, right? So 7.8 is the average K reading. So we have to add 1 millimeter in the average K reading, and we will add 1 millimeter, and it will be 8.8 millimeter base curve or BOZR. So this is the second method. And now we will learn about the third method, that how we can calculate the exactly BOZR or base curve in soft contact lenses. The third method, we have a formula which is 337.5 over D. So we have K readings in diopters right now, in diopters, right? So 337.5 over D. So first we will take average, right, of the K readings, K1 and K2. So 44 plus 46 over 2, and it will be 90 over 2. So 45 will be the answer. So the average K reading is 45, right? And now this D is actually representing the average K reading. So we will put in the formula. So we are considering this formula right now. 337.5 over D is 45, the average K reading, right? So, and when we will solve it, the answer will be 7.50. And now finally we will add 1 millimeter. 7.50 plus 1 is equal to 8.50. So that will be our exactly proper accurate base curve in soft contact lenses. So now let's put some conditions on the BOZR. For example, the statement is add 0.75 millimeter or more than 0.75 millimeter if the lens is thick or if the lens has low water content. So actually in this slide, in this condition, in this statement, we are actually considering the amount of oxygen which is actually transmitting or absorbing from the lens and it is moving towards the cornea, right? So we are actually talking about the decay value. You know very well that what is decay value. The brief definition of the decay value is that it is the measure that how much oxygen is absorbing through the lens and passing towards the cornea, right? That how much oxygen is passing through the contact lens and it is moving towards the cornea. This is called the simply decay value, right? If the contact lens is thick and low water content, right? So for example, what does it mean when the lens is thick? You know very well that if the lens is thick, it will be very difficult for the oxygen to pass through the thick lens and move towards the cornea, right? And if the water content is less, so you know very well that water actually carries the oxygen. So low water content means low oxygen. So in both of these conditions, if the lens is thick, it will be very difficult for the oxygen to pass through the lens, right? To pass through the lens and to move towards the cornea. And in the low water content, there is already, a deficiency of the oxygen. Low water means low oxygen, right? So what will we do in this condition? For example, if you choose a contact lens of water content approximately 38 to 40% of water content, right? So this is the least value of the water content, right? You know very well that up to 40 is least, medium is up to 60, and more than 60 is high water content, right? So for example, if you choose 38 to 40% of water content of a contact lens, a soft contact lens, right, then the approximate decay value will be 20 to 30%. The soft contact lens having water content 38 to 40% will have a decay value, approximate decay value of 20 to 30%, right? So in this case, it means that it has the low water content. So this contact lens will envelop the cornea tightly. It will tighten the contact lens. The fitting will be more tighter than the normal, right? So there will be impossible for the oxygen to pass through this lens. There will be no any tear exchange between the lens and the cornea, right? Because the lens is tight, the lens is fixed on the cornea. It has enveloped the cornea so tightly, so it is difficult for the tears to exchange through the lens. It is very difficult for the tears to exchange through the lens and the oxygen to exchange from the lens and moving towards the cornea. So this drastic condition can cause edema or can cause a hypoxic condition for the contact lens, for the cornea actually, right? So to prevent this condition, what will we do? We have to add 0.7 or more, right, in the base curve. So for example, if the base curve is, for example, this is a supposed value. If the base curve is 10 millimeter, right, this is a supposed value. This is not a realistic value. This is a supposed value. If the base curve is 10 millimeter, right, we will add 0.7 or 0.8 or 0.9 or 1 mm. We can add 1 mm, right? 1 mm in the base curve. So previously the base curve was 10 millimeter, we add 1 millimeter more, and now the total base curve is 11 millimeter. For example, this is supposed value 11 millimeter. So what we have done? We have done that we have increased the base curve actually, right? And by increasing the base curve, the lens will get more flatter. If this is a smaller base curve, you see the contact lens is steeper, and this is 11, this is 10 millimeter base curve. So you see that lens is steeper, and when I increase the base curve, now you see the circle is bigger, and you see now the base curve will be bigger, and here the base curve is 10 mm, here the base curve is 11 mm. So in 10 mm base curve the lens is steep, in 11 mm the lens is flatter. So whenever by increasing the base curve, when the patient will blink, in and every blink there will be a movement of the contact lens on the surface of the cornea of 0.5 to 1 millimeter. Your lens will move 0.5 to 1 millimeter on every blink, right? So it will cause 30% of gaseous exchange. It will cause 30% of tear exchange actually, and 30% of oxygen will come through the surface exchange, right? If this is the cornea, if consider this is the cornea and this is the contact lens, right? So the 30%, if you increase the base curve, which will increase the base curve, the lens will be more flatter, and by flattening the lens, right, by flattening the lens, the 30% of the oxygen will come from the tear exchange, right? You know, this, there is a space when the line, when you will blink, the lens will move, and there will be a tear exchange between the lens and the cornea, right? The new tears will go between the lens and the cornea, and it will give and will provide oxygen to the cornea, right? And the 30% of oxygen will pass through the surface of the lens, right? So 30% of the oxygen will pass through the lens and move towards the cornea. So the nutrition of the cornea will not be compromised by doing this. So the next statement is that add 0.3 to 0.6 if the lens is thin or having high water content. So our lens is already thin, you know, our lens is already thin, and you know very well, if the lens is thin, there will be excessive exchange of oxygen towards the cornea and towards the lens. There will be enough exchange of oxygen through the thin lens. So our problem is already solved. Or if water content is high, so if there is water content, if you have used a silicone hydrogel contact lens having water content more than 60%. So if you are using silicone hydrogel contact lens, right, so it means that the content of water is already increased. So increased water content means increased oxygen, H2O, right? So there will be enough oxygen for the contact lens, for the cornea as well, right? So there will be, so for example, this is the cornea and this is the contact lens, you know, this is the contact lens. So if the contact lens is thin, so there will be a easily exchange of oxygen through the lens to the cornea, right? And if the water content is high, so if you are using silicone hydrogel which having water content more than 60%, then the matrix of the contact lens will provide oxygen to the cornea, right? So there will be no any hypoxic condition for the cornea. There will be no any edematous conditions for the cornea. So I hope you find this lecture as easy and very interesting. We'll see you in the next videos.